Let's talk about the Kotlin language. You're going to find that Kotlin is not very different from other languages you've used, whether it be Java, C#, Python. It is an object-oriented programming language, but has a few advantages, I think, in developing for Android. So we'll talk a little bit about the Kotlin history, and then we'll look at how do we do comments, basic data containers, data types in Kotlin, math operators and methods, strings, conditional structures, and repetition structures in this lesson. Since we're talking about Android development, let's talk just briefly about Android as a platform. Android Inc. was founded in 2003. Their goal was to develop better interfaces for digital cameras. One of the founders, Andy Rubin, said the company would also work on developing smarter mobile devices that are more aware of its owner's location and preferences. A couple years later, Google bought Android Inc. and really began to focus on those smarter mobile devices. However, Apple beat them to the market in 2007 with the iPhone, and a year later the first Android phone came out. And the smartphone war has been going on since between Android and iOS. If we look at the mobile market shares of about 2 years ago, it was pretty split. Android had a slight advantage in the market share in the United States. But if we look at worldwide, Android enjoys a much greater mobile market share than iPhone and iPad. You don't hear much about other devices, which is a very small percent, about 2%. That tends to predominantly be BlackBerry. Kotlin was developed by JetBrains, which is a company out of Prague, Czech Republic, with offices in St. Petersburg, Moscow, Boston, New Jersey, Munich, and Amsterdam. St. Petersburg is significant in the development of Kotlin, and we'll see why in a minute. Notable products include IntelliJ, which is a popular IDE, including developing for Android, and then Android Studio, which is open source, is based on IntelliJ, and JetBrains also creates PyCharm, which is a Python IDE. They began developing Kotlin in 2011, but it wasn't released until 2016 version 1.0. By May of 2019, though, Google had announced that Kotlin would be the preferred language for Android development over Java. A lot of developers still use Java, and in Android Studio you can choose to develop with either Kotlin or Java. And those who have been doing Android development for years are still very, very comfortable in Java, and so they have pretty much stuck with it. And Kotlin is becoming a much more popular language for Android development. In May of this year, 2021, was the most recent release of Kotlin, which was version 1.5. Some of the advantages of Kotlin is it's simply just more modern. Of course, we all like to use the new modern shiny thing, but it's more concise in its programming. It saves you some time. It's not quite as verbose in many ways, which lends to improved readability. One of the significant things about Kotlin is the ability to handle nullable values much more safely. And we do that with a question mark. You'll see that as we develop Android interfaces and refer to them in code. There's a popular trend right now in computer science called functional programming, and Kotlin lends itself well to functional programming, much better than Java does. It's open source, and of course it's Java and JVM compatible, which is what the Android operating system is based on. The name comes from an island in the Baltic Sea, about 20 miles west of St. Petersburg, Russia. As I said, JetBrains has offices in St. Petersburg. So they chose Kotlin as the name for this language. It's based largely on Java, and of course Java is an island in Indonesia. It's a very small island, about 7.5 miles long and a mile wide. The island looks very beautiful, very lush greenery, although in winter I suppose it can be pretty stark with the ice and snow. And as an island with channels going into St. Petersburg for shipping and for naval uses, it is heavy maritime industry. Comments in Kotlin are really no different than what you're probably used to in using Python or C# or Java. 2 slashes create a single line comment, and that can be at the end of a statement, so anything after the 2 slashes is ignored by the compiler, and you can do a block comment with the / asterisk and concluding it with the */. Basic data containers include variables and values. So we have a keyword of var for variable. These are mutable variables. And Kotlin is a typed language, so we can declare the type of a variable using a colon and the data type. However, Kotlin is also great at inferring the data type. And so you'll see var campus equals smcc is valid, and it will infer that campus is a string data type. Once the data type is set, it cannot be changed. So classroom seats would be an integer data type. We can also declare a variable such as dog name as string and then assign a value later. And we can declare a variable as nullable. And to have that null value, we have to use a nullable data type. And each of the data types can be nulled by adding a question mark after the data type. We'll talk more about nullable data types later. I can then reassign the variable by simply referencing it and giving it a new value. We also have the val keyword. So the val keyword is a value, it's a constant. So this is an immutable variable. So we can set val office equal to a particular string, and again, we can infer data types or we can express data types with the colon. If we try to reassign a value to a value data type, we'll get an error. Naming conventions include that data types must start with a letter A through Z. Generally, we use lowercase to start. They can contain numbers, and they can contain an underscore. Traditionally, most developers use camel casing rather than the underscores, where we're capitalizing each letter of subsequent words. And I would strongly suggest use meaningful names so it's more readable. We can also cast values using the to method. So toString is pretty popular in other languages. There's also a toDouble, a toInt, a toFloat, that we can cast a variable to another data type. We also have lists. Lists are basically arrays. So there are mutable list and immutable list. If I just declare a list such as val read-only list equals list of and pass it the values I want to put in that list, it is immutable. Now the interesting thing is we've said val is an immutable constant, but you can change the contents of a val mutable list. So I can create val grocery list equals mutable list of, and then later add more items to that val list. What I can't do is reassign a whole new list to the val list. Of course, most lists will probably we'll often declare list as variables. So we have my list, and the data type here is a mutable list. It's a generic, and so in the brackets we can just declare the data type of that list. And there we can use list of. We can add values to a list. So if I add 21, it's going to append it to the end. We can also in add specify a index number. So here it's going to index 3 will become 60 and everything else moves down to the right. So you'll see 60 is placed in the middle there. We can also add multiple items by using add all, specifying an index or where we want it to place, and then the list of and the values we want to add. So we're adding a list inside of a list to expand that list. We can remove an element by specifying the index. We can get the count of how many items there are, and we can also determine if the list contains a value, and that returns a Boolean true or false. Data types. So for whole numbers, int is the primary data type. It has a range of plus or minus 2 billion, whereas a long has a range of plus or minus 9 quadrillion, and you see the exact number there as far as the top range. We also have short, which is value of about 65,000, and byte, which of course is the value between 0 and 255. For floating points or decimals, we have the double, which has a much larger number of significant digits, and float, which is a smaller number of significant digits. And then we have string data types, which are alphanumeric, characters, which are a single alphanumeric character, Boolean true or false. We can develop classes. That includes objects such as text box or button, which are references to class objects. Concatenation in strings is done with the plus sign. So plus is both the concatenation operator and the addition operator for math. So contextually it knows which operation to do. No different than other languages that you've used. Some of the methods here, there's a length method that returns the number of characters. index of returns the index of the first location of the value that's specified, and we have a last index of, where we can look for the value specified from the end. It returns the index as well. We can specify individual letters by using brackets, much like we would in a list, to pull out an element. So really a string is a list of characters. And we can pull those individual characters out by referencing the index. We have uppercase and lowercase. These are immutable, so they don't change the string. They are used more for assigning a string to another string variable or printing out a string. Likewise, there's a capitalize, which capitalizes the first letter, and a decapitalize, which lowercases the first letter. And then, of course, there are methods for trimming all the spaces from the beginning and from the end with trim start and trim last. There's a whole lot of other methods available in strings, but those are the main ones, and we'll look at some more down the road. You can also do raw strings by using 3 double quotes and then specifying your string using new line characters, tabs, spaces, and then concluding with 3 quotes. You can also trim and indentation with the trim indent method of strings. For math, we have the traditional operators of plus, minus, multiplication being an asterisk, and division. And division does take into account the data types of the dividend and divisor. If they are both integers, then it will do integer division. Otherwise, if they're both float or both double, it will do decimal division. There are the compound operators of plus equals, minus equals, multiplication equals, and division equals that you find in other languages. Kotlin does have a math class that you can import, so kotlin.math.asterisk. And there's lots of different methods that you can use then. One of the popular ones is pow, which does exponentiation. So if x is 5.0, and then pow x raised to the power of 2, of course, will give us 25. But there are methods for doing absolutes, finding the ceiling of a value, so the integer just above whatever value is referenced, as well as the floor, the integer just below. I often do a project with my students where we have to find the hypotenuse of a triangle given sides A and B, or the 2 shorter sides. Here I did X and Y. It's kind of cool that Kotlin has a hypotenuse method built in, which of course is the square root of x squared plus y squared. We can find a max value of 2 values or a minimum of 2 values. We can round to an integer, we can find the square root, and then there are 2 methods where we put the value inside the parentheses, and we can truncate. We can also round using that type of method. So the round of x is the same as x dot round to int. Conditionals, we have the traditional if conditional. We're going to have an expression do something if it's true. There's an if else, to have a true fork and a false fork. And there's an if else structure, and we can have as many else if forks as we need. And if none of the else if expressions are true, then we have an else default. Kotlin doesn't have a ternary operator, but you can do a ternary like statement in which you can apply a value to a container based on an expression being true or false. So in the example here, z would be x if x is greater than y, otherwise z would be take on the value of y. Kotlin has a when structure, which is very similar to the switch structures you find in other languages, with multiple forks available to us in matching a container value. So each of the matches has a value and then a hyphen greater than symbol, to basically an arrow, and then the statement of what's executed if that value is a match. You can have multiple values together on the left-hand side. You can also have multiple statements in a block using the brackets. Expressions are okay as far as matches, so we could have something like, does the container match x minus y? We can also ask, is the container in a range or not in a range? So the exclamation mark there is our not operator. So for complex booleans, we have the not, we have the 2 ampersands for and the 2 vertical pipes for or. We can also check to see if the container is in a list. Or we can check the data type, like is double. And then there's an else fork. If there are no matches, we can have our application do something as a default. For repetitions, we have the for structure of a fixed iteration, and we can iterate through the items in a list. We can go iterate through the items in a range, and ranges are beginning value, 2 periods, and ending value. We can also decrement through a range using the down to command, and we can also step by a certain increment. So in this case, for I in 10 down to 0, it would go 10, 8, 6, 4, 2, 0. We also have a while repetition, much like we do in other languages. We can do something while that expression is true, and we can evaluate the expression at the end with a do while. And there's a for each repetition for iterating through a list. So those are the basics of Kotlin. We'll explore things like functions and object-oriented programming in future lessons. The Kotlin Foundation, which is the moderator of the Kotlin language, provides documentation of the language. So if you go to kotlinlang.org, on their website, you will find a Docs menu. So I'm going to click Docs up here in the top. And there's information here about different areas of Kotlin. I'm going to click on Basics and click Basic Syntax. And then over here on the right, I now have a submenu for a lot of the stuff we just discussed in terms of variables, comments, for loop, while loop, when, ranges. You can dig deeper into any of those categories using the documentation provided here at kotlin.lang. There's also a cool playground. I'm going to explore that in the next video along with the Kotlin REPL. If you just jumped into this video, you can see all the videos from the Android App Development Cohort playlist by clicking on the image in the lower right. And if you'd like to be alerted to future videos that I create, you can click my picture up in the top right and subscribe to the channel.